and welcome to The Conversation. My name is Athena, and I will be your host for this first segment. I am joined by our resident astronomer, Jared, and I am also joined by our Mars One candidate, Josh. And we also have Lisa behind us, who will be producing the show. And today in news, we have...
A cold, faraway place gets itself a nickname.
And the humanities star burns up.
Then in our second segment, we will be interviewing Dr. Chris McKay from NASA Ames Research Center on the search for life in our solar system. And in our third segment, we will be taking a look at your comments and questions from last week's show. This is Tomorrow 11.12.
Good morning. How's everything up in the sky?
I want to give a huge thank you to our Escape Velocity citizens. These people give us $10 per episode on Patreon or $30 a month on Maker Support. They get a lot of awesome things, including their name in the show in all three segments, access to our exclusive citizen-only hangouts, early access to After Dark as soon as it's available on demand, early access to a view-only copy of the show rundown, free worldwide shipping in the Tomorrow Swag Store, read-only access on the Tomorrow Host channel, that is a future reward, and voting rights on upcoming roundtable discussions, and access to our Escape Velocity Discord channel, where new show ideas are born. Now, for this first thing, there was a launch recently this past week. Why don't you tell us a little bit about that, Josh?
For sure. So Soyuz FG was launched out of Baikonur Cosmodrome in Kazakhstan on Wednesday, March 21st at 17:44 UTC. On board, we had Expedition 5556, led by Commander Oleg Artemyev, flight engineer Drew Feustel, and Ricky Arnold was on board as well. So during Expedition 55, the researchers will be studying the Earth atmospherics, the effects of microgravity on bone marrow, material response to space environments, and biological sample response to simulated gravity. So they were all on board Soyuz MS-08 spacecraft. And it's obviously got 4 liquid-fueled strap-on boosters falling away after about 2 minutes after the liftoff. So I think we've actually got footage of the launch itself. So let's have a look.
Initiated. Now launch command issued for ignition.
And there you can see the engine starting to fire, ramping up. The second umbilical tower already separated.
Engine at
80% and liftoff. Drew Feustel, Oleg Artemyev, and Ricky Arnold.
So 8 minutes and 45 seconds after the launch, the third stage engine shut down and the Soyuz MS-08 spacecraft was essentially released. So you can see it launching off into the darkness of the night sky in Kazakhstan there. So
Beautiful.
Wow. That is such a cool image. I love actually watching like these launches. This is so cool. Wow.
And the Soyuz had such a long heritage of flight as well. So it's just fantastic to see this launch system still being used.
Yeah, I love it. I also love the definition of Soyuz, which is Russian for union, which I think is really cool. And just, oh, look at that. The light diffraction.
It's so pretty.
It's so pretty. It's like
good.
a star in the sky.
Look at it go.
Look at it go.
So I think after this we've actually got a little bit of footage as well of the Soyuz actually docking with the Upper Poisk module. They actually used the 2 rather than the half-day rendezvous that we've kind of become familiar with. They decided to take a little bit longer to get up there. Not entirely sure why they opted for the 2-day rendezvous, but everything was on schedule, but they went with it anyway. So it actually docked with the Upper Poisk module on Friday, March 23rd at 1940 UTC. So a bit of a longer trip to get up there for those guys than they're probably used to.
Yeah, I can't imagine an extra, usually it's half day, and this was a 2-day rendezvous.
2 days stuck in a little tin can. So I don't know if that'd be fun for me, but something different.
Yeah, the only reason I can't think of any reasons really off of the top of my head as to why they would do the two-day rendezvous. Maybe they needed to just clear out a docking port somewhere, or the beta angle where the sun's at relative to the space station made that. But I do remember reading somewhere on Twitter that they actually rotated the space station 180 degrees in order to get it lined up with this for docking. So. And then there's the data. I love that they just put the data
Straight over the top.
right over the top of it.
Sorry, do you want
cool.
to see the space station? No. No.
No.
Red numbers.
Yeah. Here's what the Soyuz is doing. So.
Yeah, we've actually got a few people in the chat saying that it may have been because it was the launch was pushed back a few days, and then they say last month had
yeah.
it too. Yeah, so Tech WKD in the chat says that. Or tech. So
Wicked.
To Wicked?
To Wicked?
Yeah.
To Wicked.
because it's not capitalized, so I was like, oh, it's totally like an acronym. But okay, to Wicked. That's pretty cool. Awesome. Okay, well that was a pretty cool launch. And so speaking of name definitions, the name of it was Soyuz, as I said, which means Union in Russian. I want to talk a little bit about naming things out in space. Jared,
What's in a name?
what's in a name?
So that which we call a rose, by any other name would smell as sweet. So because we were talking about humanities last week, so I thought let's throw some Shakespeare in it. And
I vote.
I'm sure the name 2014 MU69 would not smell as sweet. So we have naming conventions in astronomy, and 2014 MU69, which is the next target that New Horizons is going to go past on January 1st, 2019. When we look at that name, it tells us that it was discovered in 2014. So they did a survey with Hubble in order to find it. And MU69 requires a bit of a breakdown. That M means that it was discovered between June 16th and 30th. And then the U indicates that it was the 20th object discovered in that specific half month. And then the 69 tells us that it took us 69 cycles through the alphabet to actually get to that point in that cycle. So before that, 69 cycles of 26 objects occurred before we found it in that time period. So that's naming conventions, in case you ever wondered, what the heck, how the heck does this work? So that's all fine and dandy when you're telling astronomers what an object has been found. And by the way, even though I do this for a living, I still have to look stuff like that up. So for help getting the public excited about an object, though, you kind of need an actual name. But one hasn't been chosen yet for 2014 MU69. So Alan Stern and his team have given a provisional nickname to this Kuiper Belt object, Ultima Thule. Now, medieval map makers would note what they assumed was the undiscovered land furthest north of where they were as a Thule, and this stood in for a mysterious place beyond the present borders. Now, the name was chosen from 37 names that were nominated by the public and then were ranked by the public. Ultima was added on as the team felt that this object specifically was special, set to be the furthest object ever explored in our solar system by a craft only 6.4 billion kilometers away from us. Now, we know very little about this object. Look at this image. That's what we got from Hubble. So yeah, we know that it's a classic Kuiper Belt object beyond its orbit. Its relative size is about 30 kilometers across, and also the light that we get from it suggests that it's quite red in color. Now, other data that we've gotten suggests that this is a lobed object, like two objects that maybe came in contact with each other, and it may actually have a tiny moonlet orbiting around it. But studying objects like 2014 MU69, or now Ultima Thule, for now, they provide a prime view into the early formation of our solar system. Kuiper Belt objects are the leftovers of our solar system's formation from 4.6 billion years ago. Best of all, they're far enough from the influence of the sun, which means they've been relatively unchanged since formation. So this basically makes them very precise time capsules of what the past of our solar system looks like. Now, the actual final name for 2014 MU69 will be designated by the International Astronomical Union in 2019, although the New Horizons team, they're planning to formally submit a name after the flyby, which is set to occur on New Year's Day 2019. And it will literally be like just in New Year's Day 2019. Awesome. It's going to be like 12:45 a.m. January 1st, 2019, Eastern Standard Time at the time. Wow. So you all will be partying hard. Us astronomers will be be like both partying hard and like waiting for the first data to come in.
Yeah,
So,
like the very first, yeah.
so I'm really excited about that. Just more than just a party with my friends to look forward to on New Year's Day and chasing the hangover and other things. But you know, we're gonna have some really great images of the furthest object ever explored by an actual spacecraft in our solar system, and I'm really excited.
Oh,
for
that's
that.
so exciting! Maybe we can
Yeah.
maybe we can listen to the Ultima Thule, which is apparently a Swedish band. I see that.
Oh, sick!
There you go.
Zapfan and from YouTube just
Zapfan,
commented, which is pretty cool. It says that it's also a Swedish band, so we'll have to be listening to that on New Year's Day.
Nice. Yeah, I'm gonna have
Which
to
is really exciting.
pull it up on Spotify.
That is such a cool thing. Yeah, anything from like the Kuiper Belt, man, like that is just. That's so
Yeah.
cool. And then someone else was commented in here. Some of these acronyms are quite a mouthful. This was from Mans of Sand from YouTube. Loving your comment. Names are easier except for the I don't even know how to say that properly.
Oumuamua.
Oumuamua.
Yeah.
Oumuamua. I've said it like many times.
Yeah, which if I recall correctly, so that's the interstellar object that came through our solar system
Yes,
that we
looks like a
discovered
cigar.
back in October. If I recall correctly, that's actually native Hawaiian for messenger
Yes.
or like
Oh.
seeker.
Yes.
So it's a very appropriate name for that object. So,
It is, yeah. That's
So-
really cool. Loving your
It's really
comments
cool.
in the group
Yeah.
chat, guys. So now bring it over to Josh. So you wanted to talk. It says a humanity star.
I was
like
going to
this
say,
whole-
Humanity Star sounds way cooler than like 2014 MU69 or whatever. Like,
Serious?
it's
I'm
just
not
like
going to deny
Humanity
it. It
Star.
sounds pretty
Yeah.
good.
It's not a competition.
Well, it's maybe have
but
naming conventions.
Yeah.
I'm winning.
I mean,
Yeah.
I'm not going to disagree. So I wonder what we should just end up calling it. You guys have any proposals of what we should call it?
I don't know. I
So-
feel like, 2014 MU69s are going to last longer than Humanity Star did, considering it disintegrated the other morning.
Yeah.
Just someone's disco ball burst into flames.
Yeah. Someone's disco ball bursted into flames. Oh man.
So,
If you guys
obviously-
have any
The
better
day-
suggestions, leave it in the chat.
It's the disco demolition.
So obviously the Humanity Star was launched aboard Rocket Lab's successful launch, and absolutely extraordinary, this idea of bringing people together to see this amazing thing hurtling through the sky, looking gorgeous. They hoped that it would potentially last 9 months. It has just disintegrated 3 a.m. on Friday morning New Zealand time, so 1400 Thursday GMT. It came down essentially because it's incredibly light. The whole thing's about 8 kilos. It's made out of carbon fibre and large surface area, so it's caught the atmosphere, and after 2 months, it's descended. So Rocket Lab has been monitoring the entire time how people have been reacting to the launch, and Rocket Lab CEO Peter Beck has said that the positive messages have exceeded the negative ones by a ratio of about 9-1. So there's been a lot of talk about how, astronomers have gotten very upset about this whole thing, and people sort of being concerned about this glittering ball through the sky ruining their images. But ultimately it was about starting a conversation. So the exact quote I've got here from Peter Beck is that although there are a few people that it doesn't sparkle with, the vast majority of people are inspired. It's just incredible to see how many people have been thinking and pondering about it. So they were also very careful about where they launched it into orbit in the first place, so that it would not necessarily be interrupting these shots, these photographs that astronomers are trying to take. It'd be primarily be visible at dawn and dusk. So they don't have to worry about it anymore because it burst into flames when it hit the upper atmosphere. So there you go.
Yeah, I gotta say, there was a really big hullabaloo about it after it was launched, a genuinely unnecessary hullabaloo from the astronomical community, because at dusk you'll often take calibration images, but you know where it is, you know what orbit it's in, and it wasn't actually that bright. I was seeing like magnitude 8 is where it was peaking at, which, to give you an idea, your eyes, the lower limit of what your eyes can see is magnitude 6. So this was in general for astronomy a non-issue. I feel like it was a little bit of an issue because we just want to make sure that people aren't launching any random thing they want to into orbit around the Earth. That to me feels like a genuine concern. But in terms of how the astronomical community interacted with it, it was
Surprising.
Yeah, very surprising.
it was just come on, guys, like just chill out.
I've got to admit, that footage we just saw then, that is the first time I've actually seen the Humanity Star. I was out there trying to look for it all the time.
Me
That is
too.
the first time I've seen it.
I never saw it. So, yeah.
Yeah, I also did not see that.
Yeah.
So
I mean, honestly, there's other satellites out there that are a lot brighter than that. I mean, if it really was a problem for astronomy, astronomers would be complaining about iridium flares in space station passes and satellites in geosynchronous orbit, but I don't really see them complaining about that.
Someone rediscovered Mars recently. As far as, I mean,
well, it was a good test to figure out what happens when you get a very bright transient object that just so happens to turn out to be the 4th planet in your solar system. So, nobody's perfect, okay?
No, yes.
So,
oh, man. So speaking of really bright objects out there, Jared, you're talking a little bit about galaxies, is this?
yeah, so there's been a really interesting study that was published in the Royal Astronomical Society's monthly journal. And, understanding galaxies are very important and fundamental to our overall knowledge of the universe at a large scale. And there's been a similarity in a multitude of galaxies that were looked at in this study, which is that they found that the outer edges of the galaxy's disks, they appear to rotate once every billion years, but not like that's one galaxy doing that, but all of them, irregardless of their shape, as long as they have a disk, they appear to all be rotating once every billion years. So it looks like the size and the density also caused this rotation to remain completely unaffected. This study was conducted by the International Center for Radio Astronomy Research, and they note that they need to do additional research in order to confirm this, and that's already underway to assure that this discovery is real and not just biased by what type of galaxies that they're actually selecting. The models suggested that only younger stars and gas should be found along the edges of these galaxies, but when you look at the actual data itself, it shows that younger and older stars are kind of mingling together around in the same areas. Now, this is helping astronomers narrow down just where galaxies end. Essentially, what is the actual edge of a galaxy? And this is super important in attempting to figure out just where you're going to observe. Because narrow fields of view are extremely important in studies of galaxies. Extra data can translate into wasted time, wasted effort, wasted computing power, and models that don't exactly line up with what you want to do, which then leads to wasted time, wasted effort, wasted computing power, and a whole bunch of other things like that. Now, this is immensely important as a study as well, because the next generation of radio telescopes are about to come online, especially the Square Kilometer Array, which should be coming online in the early 2020s. The Square Kilometer Array, it's going to generate enough data to fill Google's estimated data storage capacity in under 2 weeks.
Wait, what?
That's how much data. It's literally 1 to 3 exabytes of data per day from this one radio telescope.
That's insane.
This study is super important because we need to make sure that all the data we're getting is like actual valid data.
Yeah.
And so the study was originally done just to see where the edges of galaxies are, but as a byproduct of it, they ended up finding out that the rotations of these galaxies, the period of rotation appears to be the same. So they're going to continue to move forward with this. And this is sort of, this has been really cool because that's a lot of data you got to manage. And that's actually changed not just how astronomy handles data management, but just in general data management when you're dealing with things that big. So, yeah. And from what I understand, the Square Kilometer Array in 1 month could generate the entire amount of data that's used on the internet. So that's a lot of data.
That's
a lot
so
of stuff.
much
Yeah,
data.
it's a lot of cat photos.
And that's why we're really excited about that, because
Yeah.
then we can plug that into models and see if we can make them even more accurate. So 2020s is going to be sick.
That's going to be so cool. I actually got a question for you from the chat. I actually don't know the answer to this. Johnny Spacer asks, could the spin of galaxies be a byproduct of the Big Bang?
So the present idea is that the rotation of galaxies is caused by the influence of gravity, both from baryonic matter, what you and I are made out of, the sparkly bits of the universe, as Astro Katie says, and the gravitational interaction of dark matter as well.
Right.
And those two things combined together sort of allow it to occur with the rotation of those galaxies. So.
Yeah, okay.
And remember,
cool.
this was for galaxies with disks. So we're talking about like spiral and some irregularly shaped galaxies. Elliptical galaxies don't have disks. They're basically big balls, like spheres out there. Elliptical galaxies, not confirmed for not flat. So there you go. So we weren't looking at ellipticals. We were looking at those spiral galaxies.
The spiral galaxies, which are like the coolest, like the world.
They're the
galaxy.
prettiest.
They're so
definitely.
pretty looking.
So.
That's amazing. Okay, awesome. Cool. Well, we are going to take a break now. And up next in your second segment, we have Space Mike interviewing Dr. Chris McKay on the search for life in our solar system.
so much
I'm
fun.
super excited. So stay tuned. We will talk with you guys soon.
Look into her face, determination in her eyes. She won't give up or quit or fumble little fashion lines. Filled with awesome expectation. This girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking. She's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking. She's fire walking to be free.
And welcome back. Before we get started with our interview today, we did want to give a huge shout out to all of our Escape Velocity citizens who have been helping to donate to the show. Our Escape Velocity citizens have been donating $10 per episode on Patreon or $30 a month on makersupport.com and get lots of benefits for that. But we also have our Orbital citizens who have been giving us $5 per episode on Patreon or $15 a month on Maker Support. They of course, get their name in the show for both the second and third segments, access to our exclusive citizen-only hangouts, early access to After Dark, and a whole bunch more. So if you are interested in finding out what those benefits are and to help support the show, please visit patreon.com or makersupport.com/TMRO. And joining us today is Dr. Chris McKay from the Ames Research Center. Thank you very much for joining us today.
Happy to be here.
So today we wanted to talk about quite a few things and looking at life in the solar system. But first I did want to talk a little bit about your career and how you got started at the NASA Ames Research Center and a lot of the different research that you've done over the years, especially looking in extreme environments here on Earth for potential life that can survive in hazardous environments. So can you tell us a little bit about how you got started on this path?
Well, everything I do centers around the search for life on other worlds in our solar system. I got started on it when the Viking results came in the late 70s. Viking was our first search for life mission. In fact, so far it's been our only search for life mission. It went to Mars, and the results were really puzzling. But they opened up the question: could there be life on other worlds, and how do we search for it? And all the work I've been doing in extreme environments and on space missions and on planning for future missions center around the question: is there life on other worlds, and how do we search for it? And since the Viking times, the list of worlds that are of interest has expanded.
Wow. And with that, a lot of the different worlds that we've been discovering and a lot of the different data that we've gotten from missions over the years has really transformed that view. And let's talk about some of the missions that you have been a co-investigator on. Probably the one that was most exciting to me was the Huygens probe, landing at Titan in 2005. And how surprising were the results from that, of especially the atmosphere and the environment there at Titan?
Well, the Titan results. Titan is an interesting world. It's one of the worlds that's in some ways the most interesting, because we know that there's a liquid on the surface of Titan, but that liquid is not water. And so Titan gives us a chance to ask the question: can other liquids besides water be suitable liquids for life? And so Titan is puzzling in the sense that we don't know how to search for life that's not based on water. But it also holds out the possibility that we'll find something there that's truly different, truly a second genesis of life.
Wow. And do you feel like something that I've wondered about is that the conditions there are similar to what Earth's conditions were several billion years ago? Do you feel like just given enough time and enough natural course that Titan would become a habitable place for humanity, or at least life that exists here on Earth?
Well, in a sense, Titan is similar to the early Earth, or at least our conceptions of the early Earth, in that there seems to be non-biological processes going on Titan, or there are non-biological processes going on Titan that are producing organic material. But the big difference between Titan and the early Earth is, on early Earth, the liquid into which these organics were falling was water, whereas on Titan, the liquid into which these organics are falling is liquid methane at minus 180 centigrade. So that's a fundamental difference in what the potential for how those molecules turn into living systems. it is true that as the sun gets brighter, particularly when it goes into the red giant phase billions of years from now, Titan will be warm enough that the ice in its crust will turn into water, and it will then be more literally like early Earth. But for now, Titan gives us two possibilities: understanding how nature can make organics without biology being involved, and as a target, a possible target for the search for life in a different liquid than liquid water.
And with that, with the whole kind of transition more looking towards liquid water, and with I wouldn't necessarily call it a distraction, but looking at all of these moons that we are detecting might have subsurface oceans or at least large deposits of ice. Do you think that with those new discoveries that there won't necessarily be any follow-up missions to Titan anytime in the near future?
Oh, there will certainly be follow-up missions to Titan. In fact, in the current competition for the New Frontiers mission, the next big billion-dollar mission at NASA, there's two finalists. One of them is a Titan mission. It would basically be a eight-blade drone landing on the surface of Titan and flying around. The other mission is a comet sample return. So Titan is very much on the priority list. It's very interesting, both the organic chemistry and, to me, the question of could there be life in that liquid. So Titan is still on the agenda. But as you mentioned, these ocean worlds, ice-covered ocean worlds, have really become very fascinating as well, Europa and Enceladus in particular, and there'll certainly be missions to those worlds also.
And let's talk about Enceladus for a little bit. With that discovery, there are some camps that believe that there might be more potential for life to exist at Enceladus than there is even at Europa. And what do you feel about that?
Well, I think what we can say for sure is that we know more about Enceladus, and what we know from analysis of the plume. Remember, Enceladus has a plume of water coming out of its south pole, and it's clear that that plume is coming from an ocean. It's clear that that ocean has hydrothermal vents in it. There's organics, carbon as organic material in the plume, and there's biologically available nitrogen in the plume, and there's a chemical energy source that at least some microorganisms on Earth, methanogens, could use. So in that sense, we know a lot about Enceladus, and we've determined it directly in the plume, and we can access the plume. So in that sense, Enceladus has all the major requirements for a life-bearing environment, and the samples are accessible. So for that reason, I would say it should be high, and in fact, I would say number one on our list of where to go and search for evidence of life. Europa is a bigger world, maybe a longer-lived world, and may be a better world in terms of life, but it's certainly not a better world in terms of accessibility to the ocean and to the samples that we would want to investigate. So practical designs for a mission have to fold together not just how ideal is the target, but how accessible is the stuff you want to look for, and what do we know right now? On Enceladus, we know a lot. On Europa, all we really know is that there's a big ocean down there. We've never yet detected organic material or nitrogen or a suitable energy source. We expect them to be there, but we haven't detected them.
What would it take in order for us to be able to detect it? What sort of instruments and what sort of mission would we need in order to do that?
Well, the next mission to Europa, the one that's being built right now and will fly soon, is called Europa Clipper, and it will fly by Europa and basically do a geophysical maps of the surface, give us an understanding of the thickness of the ice and the distribution of the ice and how that works. And I think that mission will put us in a good position to then map out further strategies for how to search for evidence of life or how to access the ocean. Based on what we know right now, which is limited because that Ice Clipper mission hasn't gone yet, but based on what we know right now, my guess is that we're going to have to get through the ice to the ocean, that Europa is going to hold her secrets tight. And to get to that ocean, we're going to have to go through 10 kilometers or more of ice. That's a big challenge. It's not something that we can do now or with technology that we can see anytime soon. But that's what we're going to have to do, I'm afraid, in terms of reaching the water on Europa.
And in order to do that, that brings up an interesting question that I wanted to bring up from the chat room from Travis Neal. He says, question for the doc, does the investigation for life on other planets and bodies infer non-contamination, and how does that impact space capitalists' pursuits? So since we would have to drill that far, what sort of procedures with that and some other missions that I want to talk about dealing with non-contamination?
That's a very important point. You don't want to build $1 billion mission and fly it all the way to Enceladus and then find something and realize that it's fingerprint oil from a scientist or a technician who is building the instrument. So you have to worry in very exquisitely about contamination control and making sure that your instruments are clean and that the samples that they select, that they characterize, are indeed samples from the environment you're investigating, not contamination you brought from Earth. That has been a problem, and it's a challenge. And we know how to do it. It's just hard, but we know how to do it. The other part of the question is, what about contamination by other actors? That's more of an issue for Mars than anywhere else. There are no private missions going to Enceladus yet, unfortunately, and certainly no human exploration of the outer solar system yet, unfortunately. But Mars is clearly in the agenda list of private companies. Mars One, for example, SpaceX. The list is probably longer, and I hope it gets even longer. And indeed, we'd have to think carefully about what are the rules that those kind of companies would follow to prevent contamination. Well, fortunately, we have a framework in place, an international framework set by the Space Treaty, and all the countries that are signatories to that Space Treaty, their space programs and their citizens or companies operating within those countries are bound by the rules of the Space Treaty. And that Space Treaty does specify that contamination should be avoided. How that translates into detailed rules and what you can and can't do has yet to be done. That translation tends not to get done until there's a reason to do it. And as private companies mount missions to Mars, these rules will get fleshed out. I'm not worried. I think there's very little chance that anything humans can do will contaminate Mars because the environment there is just so hostile. Any organisms that are released from a spacesuit, for example, will just be killed very, very quickly in the low pressure UV environment of Mars.
Sure. And speaking of Mars, I wanted to talk a little bit about the Mars Phoenix lander and a possible follow-up mission that you're looking to be possibly doing for that. What was it that what goals did you set out when you were looking at the Mars Phoenix lander? What especially were you looking to find?
Well, I was part of the Phoenix mission. It was a lander that landed in the north polar regions of Mars. And the goal was to go after the ice. You always hear follow the water, but on Mars, the real way to approach it is follow the ice. Follow the ice. And we had results from orbit that there was ice in the polar regions. Its mission was to land and reach that ice, dig down to that ice and investigate that environment. And it was phenomenally successful. It did reach the ice, and it also made a very surprise discovery, the presence of perchlorate in the soil on Mars. It's a type of salt, chlorine bound to 4 oxygen atoms. Anybody with experience in rockets, amateur rocket building and launching will know that perchlorate is what's used in solid rocket fuel. So it's not expected on Mars, but in fact has a lot of implications for how we do search for life or search for organics. So it was the biggest surprise from the Phoenix result. The follow-up mission that we'd like to do, which would go back to the Phoenix site, which we've called Icebreaker, that mission would drill down deeply into the ice and look for evidence of life preserved in the ice. Ice is a very good preservative, which is why we freeze food, for example, or we freeze biological samples. So we might be able to drill down into the ice at the Phoenix site and find organisms that were alive just 5 million years ago and are now frozen and entombed in that ice. So that's one of the missions we would like to do on Mars, focused on the search for life.
So, hypothetically speaking, if we find organisms that existed millions or even billions of years ago at Mars, but we don't find anything that is currently alive at Mars, at what point do we say, okay, do we start purposefully contaminating and seeding and introducing microorganisms that could possibly survive in this environment? At what point do we move towards that stage?
Right. That's a very important question. Just as background, let me just mention that we have already contaminated Mars. We have on Mars now about 500,000 viable Earth microorganisms. They are inside the spacecraft. that we've sent to Mars. We stopped sterilizing spacecraft after Viking. So missions to Mars now have a requirement of cleanliness and a certain level of microorganisms. But if you add that up, starting with Pathfinder and going through even the failed missions like Beagle 2, they each carry on average about 300,000 microorganisms to Mars. Most of those die when the spacecraft reaches Mars because they're exposed to the ultraviolet light. But any organisms inside the spacecraft, say sitting on the motherboard on the central computer, would be fine. They're not growing, they're not metabolizing, they're not reproducing, but they're not dying either. They will be slowly killed over thousands and thousands of years by cosmic rays. So Mars already has Earthlings. We know that for a fact. We've documented it. We know where they are, though. And we could, in principle, remove them all if we were motivated to do so by the discovery of an indigenous biology. But the real essence of your question is, when do you know when the answer is no? And that's very hard to define. Finding an answer that's yes is clear and easy. You say, I found life. Here's its nature. We can compare it to Earth life. Is it a second genesis? Is it not? But if you don't find life, then you're not sure that it's just because you haven't looked in the right place, right? So it's going to be very hard to reach an international consensus that we've done enough looking on Mars that we can declare it lifeless and, figuratively speaking, move in and have unconstrained Earth biological interactions on Mars. That might happen, but it's hard to predict when.
And from the chat room, a couple of questions related to this. One from Sane Alex says, could the Earth not have contaminated the rest of the solar system already via asteroid impacts?
Indeed. This is a
versa.
hypothesis that must be considered. It must be considered that the planets exchange material and exchange life. Earth is not necessarily the logical place to be the source of it. In fact, Mars is potentially a better source, and many scientists would favor the scenario where life starts on Mars. It had a happier childhood than the Earth anyway, because Earth suffered from the moon forming impact, and life spread to Earth from Mars. And Mars is a better source because of lower gravity, thinner atmosphere. It's easier to kick stuff up. But I was recently reading a paper which made the bold suggestion that the best source is Enceladus. Here you've got this incubator, hydrothermal incubator, that's automatically jetting a stream of stuff into space, that it could have been the seed location for all life in the solar system. So indeed, we have to entertain the possibility that all life in the solar system is related. It all derives from a common mother world, and that mother world may be Mars, may be Enceladus, maybe it was Earth, but there's no reason to think that Earth would have been the most logical candidate for the mother world. Now, I would find that result disappointing. I'd be much more excited to find that Earth has its own life, Mars has its own life, Enceladus has its own life, and they're all different. They all represent separate, independent origins of life. That would be very exciting scientifically. It would also tell us very convincingly that life is common in the universe, that we do live in a biologically rich universe full of all sorts of things. And I think that'd just be cool.
A couple other questions I wanted to ask from our chat room. This one comes off of YouTube from Man of Sand. Says, could life possibly exist underground on Mars, even if not on the surface?
Sure. Life underground is in many ways better than life on the surface. Even on Earth, many extreme environments, deserts, the Antarctic dry valleys, deserts like that, life burrows underground, sometimes only just a few millimeters underground. But getting away from the harsh, dry surface is often a wise strategy in extreme environments. It's also important to note that if we drill down just about anywhere on Earth, we find life living in the subsurface, in caves and in the interstitial spaces between rocks, down to quite some depth. So life underground is a good lifestyle. I'm not recommending it for any of us, but for microorganisms, it's pretty good.
Sure. Now, hypothetically speaking, if we did get to that point where we decided that we haven't discovered any independent life on Mars, and we wanted to move forward with terraforming activities, what would be the best sort of microbes and organisms, or even plants, that might be able to exist on Mars today with minimal interference?
Yeah, if we decided that we wanted to introduce life on Mars in a purposeful way and begin warming up the planet, then the organisms that would be the logical pioneers would be the organisms that one finds on the top of a mountain. In fact, you can think of the biological future of Mars in the event of terraforming as coming down from a steep mountain. This is a metaphor that Jim Graham of the University of Wisconsin developed. I think it's a beautiful one. Imagine starting off the top of a very high mountain. And there it's just ice and snow and bare ground. And as you come down, you first encounter very simple life forms, very hardy cyanobacteria and mosses, very simple things. And then as you move down, as grasses, then eventually you hit tree line, forests, and it gets richer as you come down. That succession parallels what would be the time succession on Mars if you started warming it up and introducing life.
And another question from the chat room. This one actually comes from Twitch, from Hanny Svoverp. Says, would it be easy to tell definitively if life on Mars or anywhere else is in any way related to life on Earth?
Yeah, that's a deep question, and it's one that we struggle with, and I don't think we'll ever answer until we actually have the sample before us and are studying it. And that's one reason why I'm so fascinated with Titan. If we find life on Titan growing in liquid methane at minus 180 centigrade, there's no way that's related to life on Earth. Nobody you know lives in liquid methane. So that would be clear evidence, unambiguous evidence of a second genesis. Whereas no matter what we find on the water worlds, Mars, Europa, and Enceladus, there'll always be this nagging question. Maybe it's just a very distant ancestor, but we really are related, and there really is only one example here still. So that's a deep question, and we speculate on it, we toss it around, but I think we'll only answer it when we're faced with the organism that we're studying.
Very interesting. Something that is brought up kind of related to Titan is the idea of that whole octocopter. And a question from our chat room coming from Zapfan says, will the octocopter to Titan have an instrument for measuring hydrogen concentration in the atmosphere to see if it's depleted near the surface? And even though we're, of course, it's looking mostly for methane, we're looking for those elements as well.
Yeah, that's a very astute question. It's my favorite topic about Titan, is the possibility that life there is consuming hydrogen. And in fact, the Dragonfly mission, as it's called, the octocopter that would be sent there, will have the capability to measure hydrogen. And indeed, as the questioner indicated, finding curious depletions of hydrogen would be an indirect evidence that maybe there's something there eating it, because we don't expect any chemical process to be consuming hydrogen near the surface. So that may be the best way to get an indication there's life on Titan, because we can't look for the life itself because we have no idea what it's made out of. We don't know how biology would work in liquid methane at minus 80. We know it won't have DNA and amino acids and proteins, that's for sure, but we don't know what it will have. But the one thing we do know is that it's probably going to need energy, or it will need energy, and it will then probably consume hydrogen. So searching for hydrogen may be the way we get our first glimpse into the possibility of life on Titan. So yes, that quadcopter, octocopter will have a hydrogen detector.
Back to Mars for a moment. Rejinx from YouTube asks, what level of life on Mars would have to be enough to cause us to not colonize Mars?
Sorry, can you repeat that? I had some interference here.
No, that's okay. What level of life on Mars would, to you, be enough to cause us to not colonize Mars, in your opinion?
Well, in my view, finding any life on Mars, that is a second genesis, separate from Earth life, would be reason to reassess our plans. And at that reassessment, I would advocate for not sending Earth life, but instead enhancing the richness and diversity of that native life. regardless of how simple that native life is. On the other hand, if we find life on Mars and it's related to Earth life, it's a common origin, it shares a history with Earth life, well, then those are just our cousins and we just move in. There's not a fundamental problem, just like there isn't between different continents on Earth. It's the same one type of life in different places on Earth at the level of microorganisms.
And then another Mars question from Man of Sand from YouTube asks, have there been efforts to develop microbes which could survive on Mars? And how successful have such efforts been, if any?
There have not been efforts to develop microbes or to engineer microbes to survive on Mars. There have been efforts to search to see if there's any naturally occurring microorganisms that could survive under Mars conditions in the laboratory, and also attempts to search for organisms in extreme environments that might grow in very dry environments on Earth. And I've been particularly involved in the latter, searching for life in the dry valleys of Antarctica and in the driest desert on Earth, the Atacama Desert, for anything that can live in the dry extreme. And the answer, maybe not surprising, but somewhat disappointing to me personally, is no. We have not found any organism on Earth that can grow or reproduce without essentially being a bag of liquid water. So life seems to have that limit, that it needs to be immersed in liquid water to grow or reproduce. Now, many organisms can be dormant. They can spend even millions of years waiting for the water. But without the water, they don't grow or reproduce.
And then another question from the chat room from Hanny's Vorwerp says, do you think that most life in the universe would be photosynthesis or chemosynthesis?
That's a good question. On Earth, of course, the vast majority of the biosphere is powered by photosynthesis. Plants make biomass and we eat them. So we humans are powered by photosynthesis, for sure. There are ecosystems on Earth that are powered by chemosynthesis, but they are tiny in comparison. But on the other hand, when you look out across the solar system and across other planets around other stars, it looks like there's more potential real estate for chemosynthesis than photosynthesis. So we don't know. My guess is photosynthesis will win because those few worlds that are suitable for photosynthesis will be overrun with life. Whereas those worlds in which it's just chemosynthesis will only have little tiny bits and pieces. So the photosynthesizing biosphere will outnumber and outvote the chemosynthesis biospheres.
And related to the idea of being able to detect those different forms of life, from Lokasi in our chat room asks, is there any chance our newer telescopes that will be coming online in the next decade can detect life before a probed mission, such as a detection of a forest on an exoplanet?
Yeah, that's a good question. And that's an area of active research right now. And the first answer to it is if we see a planet that looks like the Earth, from at about the right distance and size of the Earth, and from the right distance from its central star, and that world has high levels of oxygen, then that's a very good, but not foolproof, but very good indication of life on that world, and life that is developed to the level of polluting its environment with oxygen. So that would be a very interesting result, and that result, indeed, as the questioner indicates, could come from telescopes that are on the drawing boards now, both Earth-based telescopes and orbital telescopes. Beyond that, there might be, with future advances, the ability to even see pigments, things like the colors of chlorophyll. If something absorbs light for photosynthesis, it's going to have pigments. Pigments are going to have colors. We might be able to see those. That's a little bit further down the road in terms of the technology, but that's conceivable too. And so it could be very interesting. We might have the first evidence of life, not in our solar system, but beyond it. The difference, though, is that if we detect life on a planet around another star, we'll know it's life, but we won't know whether it's related to us or not. We won't know if it's a second genesis. We can't look at its biochemistry. Whereas in our solar system, on a sample from Mars or Enceladus, we can actually look at the biochemistry of the organisms and say, and ask the question, are they related to us? How does their biochemistry and genetics compare to us? Do we have a common ancestor or do we not?
And this is kind of a pretty existential question here, but from our chat room, Rebel Ace Friesland asks, what if after it all, we find out that there is no life anywhere else than Earth?
Yeah.
What if?
Right. That we cannot rule out that rather scary conclusion that we are alone, that we are the only life, that we are the only intelligence. That's consistent with the data right now. It's not ruled out by the data, although many people, myself included, tend to think, for no factual reason, tend to think that that can't really be the answer. But it could be. It could be. And that puts, I think, an enormous responsibility on us as human beings. We are the only, if you will, guardians of that one spark of life, life being the most fascinating and phenomenal thing that we know about in the universe. We tend to take it for granted because it's all around us and we eat it for breakfast and lunch and dinner and we sweep it out the door. But when you look at it in detail, and especially when you look at the rest of the solar system and how barren of life it is, you realize how special it is. And if there's just one spark and we are the one keeper of that spark, one intelligent keeper of that spark, we better get our act together and do something. We need to assume that responsibility and move forward. And my view is that until we get evidence that it's not the case, we should act as if it is. We should act as if this is the one spark of life, and we humans are the one intelligent entities capable of spreading and sustaining that spark, and we should accept that responsibility. As we discover new life forms or maybe new intelligent species, okay, then we revise our plan of action. But in the meantime, that's, I think, what we got to do.
And that kind of relates to another question that we have from our chat room from Mr. Huggy that says, if we found no life on Mars, started to terraform and reactivated dormant life, should we stop?
Yeah. We really, that's a position we don't want to be in. We don't want to be in a position where we have altered the environment of Mars such that life from Earth is growing there, and then discover that there's an indigenous life that's a second genesis. That's the rabbits in Australia situation, and we don't want to do that. And I mentioned before that we have contaminated Mars, but that's not the rabbits in Australia situation, because Mars is not a place where any life from Earth can grow right now. That would be more like a rabbits in Antarctica situation. You put two rabbits in Antarctica, and they're just going to die, and you can pull them back anytime you want because they'll just be two dead rabbits, not far from where you left them. The rabbits in Australia problem is when you put life in an environment where that life can grow, and it grows exponentially, and then you can never get rid of it. So if we terraform or start terraforming Mars and make it suitable for Earth life to grow, we've taken our contamination to the irreversible level. It is no longer biologically reversible. Right now, everything we've done is biologically reversible. I use rabbits in Antarctica as a shorthand for that rather than rabbits in Australia, which is not reversible.
Yeah. And with all of that, a couple of questions that have been asked that I would want to kind of summarize here would be that what if we have already discovered life that we just haven't been able to recognize what type it is? Like there's unknown life, like the idea that there is different types of organisms that have a completely different set of DNA that uses like RNA instead of mitochondrial and all those types of things. Do you think that it's possible that we will or have already seen or discovered life that we just didn't recognize as life?
Well, it could be, and people have talked about the idea of what's called a shadow biosphere. The idea that there is a second genesis of life here on Earth, and we just haven't discovered it. But we can't, since we haven't discovered it, we don't know about it. We can look for it, but there's no evidence that it's there. And my intuition is that the answer will be no. That life is a winner-take-all phenomenon. That if there had been at one point two different types of life on Earth, one would have outcompeted and rendered extinct the other. But it's hard to be sure about that. And since doing missions to Earth is much cheaper than doing missions to Mars, we should certainly keep looking for the shadow biosphere. And maybe we will indeed find a second genesis of life right here in our own backyard. And that would be scientifically very, very interesting. And it would also be good evidence that the universe is full of life. Even if we have evidence of the origin of life twice here on Earth, it tells us that the origin of life is not some weird statistical fluke.
And in your opinion, do you think that there is any types of life then that could exist in the vacuum of space other than on a planetary body or a moonlet or even some sort of rock or something?
Yeah, it's hard to think about that. Remember, we have only one example of life to base everything on. And so based on that one example, we would say no. Life needs water, life needs a surface, life needs a planetary environment. But how confident can we be about any conclusions when they're based on just one data point? So my approach is, let's first go out and search for what we know, what to look for and how to look for it. And then as we learn more, we might be able to expand our understanding and expand our ability to search. So I think we have to admit ignorance on this topic. And the scientific basis for admitting that ignorance is that we only have one data point. So I don't pay too much attention to people who make detailed and confident predictions about the nature of life everywhere based on the one example we have here on Earth.
Yeah, you don't know what you don't know. Well, there's a couple of basic general questions that we would like to ask you. I don't want to take up all of your time, but I did want to ask these general questions that we like to ask all of our guests that come on and get your opinion on these. So first off, what is your favorite space mission, past, present, or future?
Well, my favorite space mission, in a sense, was Viking, because it had the bold goal of searching for life. In terms of missions now, Cassini, even though it just recently died, I still put it in the present. We're still analyzing the data because it discovered the most habitable environment in the solar system, evidence of it, the plume of Enceladus. And my favorite future mission would be robotic mission, that is, would be flying through the plume of Enceladus and bringing some of that stuff back to Earth for study.
Well, you got me curious now. What would be your favorite human mission in the future?
Well, I think that the goal for humans should be to establish a research base on Mars. And I would point to Antarctic bases as the model. These are small facilities. They may have, say, 50 people, but they're there permanently. The crews are there permanently. They're doing research, exploring Mars. I think that we've had bases in Antarctica, the U.S., for example, for 60 years now. We need to think in that sort of time frame on Mars as well.
Well, you've kind of answered our next general question, but something that we do like to ask is whether or not you believe in human or robotic exploration of the cosmos.
Yes, my answer to that is yes. They serve quite different purposes. The purposes of robotic exploration is to prepare our understanding and to prepare our technology for human exploration. And if you think about it, the goal of everything comes back down to the human experience. Science and exploration are not goals in and of themselves. They are goals in that they are useful and important in that they contribute to the goal of enhancing human and the richness of human life, right? So, I'm a scientist. That's what I do, but I don't do it because science is somehow a goal of itself. It is not a sacred cow of its own. I do it because the results of science informs humans about what humans ought to do and how they can live better and more interesting and more fulfilling lives. So I see the robotic exploration of Mars, and in fact, the rest of the solar system, as our way of assessing how are we going to integrate these worlds into our human experience? Are we going to do it? Maybe we will decide we will do it only remotely and never go, but more likely we're going to decide we want to integrate them into our human experience directly. Certainly Mars and the Moon, and by human experience I don't just mean science. It's not when people it is not the case that the only thing that people will do on Mars is science or exploration. They'll do all the other things that humans do on Earth, they'll do there too, maybe. So I resist the dichotomy that sometimes gets falsely posed within NASA. Humans versus robots, who is better at doing science? Well, that's a stupid question, because the purpose of humans is not to do science. The purpose of science is to serve humans.
Awesome. I very much agree with that. And you, just over the course of this interview, I think I already know the answer to this next question, but where do you think we should go next?
Well, actually, I think we should go next to the moon, because we have to set up a research base on the moon, a long-term research base on the moon. 60 years, not 3 days like Apollo, 60 years, because that's where we're going to learn how to do it on Mars. So my ultimate goal is Mars. I think Mars is the planet that I think we're going to learn the most from in terms of a long-term human base. But I don't see how we're going to be able to do that until we've done it on the moon. Now, I also realize that there's other reasons for having moon bases, and that's great. But my reason for supporting a moon base and going to moon meetings and saying, go moon, go, is because that's how we're going to get to Mars.
Awesome. And this is the last question we have for you, probably one of my favorites, is why space?
Well, it's a question of why anything. Why poetry? Why novels? Why gymnastics? Why space? The short answer is because we're human beings. I think space isn't qualitatively any different than any other things we do. So we do it all. Now, you can drill down into that a little bit and say space has some very interesting aspects. Possibility of discovering new things about the physical universe, possibility of discovering new biologies, different biologies that could have important implications for biotechnology and medicine and agriculture. The possibility of being a place where the human energy, the human drive that's particularly strong in some people to explore can find scope for action. So there's a lot of things about space that make it a particularly suitable arena for human activity. But I think it's the same question of why do anything? Why do we do anything? It roots down to the nature of human beings, and the nature which I think is a good nature, valuable, wonderful. It's what makes life so worth living.
Absolutely. Well, Dr. McKay, thank you very much for joining us today. This has been a very enlightening conversation, and again, thank you very much for joining us from both all of us here at TMRO and our community. And is there any final thoughts that you would like to leave us with?
Thank you. It's been very interesting talking to you, and I want to particularly thank the online folks for some very interesting and astute questions.
Yeah, our community here always never fails to amaze and always has some very great questions. So thank you very much for that. But we're going to take a quick break, and when we come back, we're going to have comments and questions from last week's show. So stay tuned for that.
Science. It both draws us together and tears us apart. Brings discoveries to cure us and threaten us. It is neither good nor evil. It is what we decide to make of it. There is so much more to learn, and we are curious. Together, let's explore the science of tomorrow.
Hello, everyone, and welcome back. Before we get into questions and comments from last week's show, Orbit 11.11, I wanted to just give a huge thank you to our citizens of tomorrow. This is our Escape Velocity citizens. They contribute $10 per episode on Patreon or $30 a month on Maker Support. These are our Orbital citizens. They contribute $5 an episode on Patreon or $15 a month on Maker Support. Then we have our suborbital citizens. They give us $2.50 per episode on Patreon or $5 a month on Maker Support. They get their name in the show during the third segment, access to our exclusive citizen-only hangouts, early access to After Dark as soon as it's available on demand, early access to a view-only copy of the show rundown, and free U.S. shipping in the TMRO Swag store. So last week, If you guys were tuning in, we had an amazing interview with Neve Shaw about why we need humanities in space. So I'm really excited to get into these comments from last week. And our first one comes from YouTube. It is Mr. Glenn Space. He says, cislunar is nice, but lunar base makes it unnecessary. The moon already is your orbiting satellite. If going there, you might as well land and conduct science. Launching further from the moon is relatively easy. Best to develop the capacity of the lunar surface. Now, what do you guys have to say about that? I think I'm kind of in his boat with this one, to be honest.
Way on his boat.
I disagree. I disagree. I think that if you're going to have a lunar base, which we should have a lunar base on the surface, we should have an orbiting station as well, or at least, you know, whatever craft that they came there in, sort of like Apollo, there should be the escape vessel essentially in orbit. So I think it's a really good idea to have a cislunar base, especially with the type of ideas that we have planned with the Gateway so far, with a lot of the robotic missions and sample return missions that'll start off at first. So it's going to be a lot easier to process a lot of different science and materials that we're going to be doing there at the surface of the moon and sending that first to the station to then be sent back to Earth. And with whenever people are involved, again, we either need to have the return space shuttle in orbit or have a station that we can launch to send, you know, whatever emergencies might come up.
Which one should be first? The on the lunar surface or like the actual orbiter first?
I don't know. That's a good question. I feel like at least we should try to put the funding into both camps at first, so that both have to kind of happen
at the same time.
Yeah, otherwise it'll be only one or the other. Yeah.
Let's do a lunar COTS and have them compete for it.
Yes.
I feel like having a lunar base and a cislunar platform, they both complement each other very, very well. Because if you put propellant at your cislunar platform, you can then carry more weight down to the lunar base, and you can also carry more weight out to wherever you're headed in the solar system as well. And your lunar base on the surface could generate propellant to use on board of your cislunar platform that then enables exploration of deep space. So, win-win.
And just like Glenn Space is saying, you know, you can launch from there as well to go to even further places, you know, doing that sort of thing, harvesting your fuel there at the surface. So,
yeah, we got a few people actually in the chat. We got Natman Allen, who actually agrees with having, a fixed lunar base with an orbiting station. And then also Raj Luthra says, I build both the moon base and lunar space station. Do you guys think it eventually lead down into the path where kind of like Earth, where we have a lot of satellites, where eventually it's like once we have one orbiting station, we might have another one and another one and another one if we have a lunar base?
Well, if we're going to have lunar bases on the far side of the moon away from the Earth, it makes sense to have satellites in orbit around the moon as a communication system. But if you're on the near side of the moon, you literally just have to point the dish at Earth. So, it stays there in the sky since the moon is tidally locked with the Earth.
Right.
So.
Yeah, we're still going to need that connection back to Earth. We can't just, unless we actually start to colonize, which is kind of not really the idea.
And the most interesting places we want to go to on the moon are the poles and the far side. So we're going to need that.
And they're difficult to get communication to. So,
Amazing. Cool.
All right. So when's Starlink going to be in orbit around the moon?
Seriously. Seriously.
That would be great. Okay, our next comment comes also off of YouTube. It's Michael Farrell. Says, is Trump's dream of a U.S. Space Force about deep space or just a very high altitude earthbound attack/defense force? And how does his version relate to existing treaties regarding the militarization of space? How does it differ from Reagan's Star Wars initiative? Which, by the way, Reagan's Star Wars initiative, for those of you guys that don't know, in 1983, Ronald Reagan, during the administration, had put in something known as the Star Wars initiative, which was a big missile defense system. He was planning to have both surface and also lunar, a ground-based and also a space-based system for protecting against missiles coming from the Soviet Union. So that's what he's referencing here. What do you guys think as far as that? Do you think that that's what Trump's plan is? With really increasing, the NASA budget.
Struggling with those two words in the same sentence.
Interesting,
I was going to say there's not been much in terms of what's been said. The only thing I know is that in general the Air Force and the Department of Defense are like, we don't need this. So that's their overall opinion about it.
I think it's funny how some of them are changing their tune now that the president has been like, oh yeah, we need a Space Force. And they're just like, oh yeah, that sounds great.
That's so
We don't need a
cool.
Space Corps. We don't need a Space Corps. But Space Force, yeah, we can get behind that. Sure, the president's okay with it. So yeah.
Yeah.
Although to answer his question, I don't know if Trump has a vision, to be honest. I think this is more Pence that's kind of driving the steering wheel as far as the White House is concerned with the NASA budgets and everything going on there. I don't know if Trump has a vision, but I might be totally wrong on that. But if he does have a vision, it might be very ludicrous.
I don't even know what form this would take. Like, that's the kind of the confusing thing. You do have missile defense systems in place through Patriot and all of that already. So what is this?
I'm imagining like a super space station that's like a barracks of like at least like 1,000 troops just hanging out there. Yeah. Training all day.
Getting lots of medical data on what it's like for people in space.
Yeah.
A pretty good point in the chat I just saw by Johnny Spacer. He says we need to defend our satellites. That's what space defense is for. So, I mean, obviously, you know, in the 1980s when the Star Wars initiative really was focused more on like missiles and being, you know, protecting our country. This is actually, how do you guys feel about this point? I think that that's pretty interesting to say. Like, okay, like our satellites, what the space defense is for, but isn't space kind of a free space in a sense? Whereas when it comes to like, I think it was with the International Space Station. Once you're in space, it's kind of like anything that's happening here on Earth is sort of put on pause temporarily.
Nothing. So the treaties
politically.
basically say you can't put weapons of mass destruction in orbit.
Right.
But that doesn't mean that you can't put like tungsten rods in orbit and then drop them out of orbit. And there's things like that. And you know, it's actually really difficult to destroy satellites. And when you attempt to destroy a satellite, it's typically really obvious what you're trying to do as well. So, you know, launching a rocket from here on the Earth, or a missile, I suppose, from here on the Earth to do that, or attempting to attack something in space, it's difficult because the physics doesn't make it easy, and it becomes like very obvious with the systems that are already in place to kind of monitor these things that are happening. So.
And realistically, a lot of the things that the Air Force generals are bringing up concerns about is cyber warfare and hacking of satellites, and you know that type of battleground happening. Not necessarily physical soldiers in space, you know, trying to protect satellites. Although that's what I'm sure Trump is imagining.
I'm picturing like cameo astronaut suits.
Yeah.
Like Starship Troopers.
Like stars,
yeah, exactly.
Would you like to know more?
But realistically, all those type of missile defense and satellite defenses, especially with cyber hacking and all that, those are programs that already exist, and it's just talking about reorganizing them, taking them away from the Air Force and the other smaller organizations that exist within the Navy and the Army, and putting it into one separate force that has its own, hopefully increased budget to be able to do those realistic types of space defense for our military stuff. So
and like exactly cybersecurity. That's all like ground-based. It's not really in space. So, okay, cool. Well, a fun note before I jump into the next comment is from Smokey Durg. It says, "Space is a safe space. It's also an unsafe space because space will kill you."
Yes.
I thought that was great. Okay, so our next comment comes off of YouTube from ADD Dude. It says, "Neve's answer to humans or robots sums up nicely why we need humanities in space. Also, great interview, Lisa. You were the best choice for this one." Yay! Great job, Lisa.
Yay, Lisa.
So again, if you guys haven't actually watched 11.11, totally bookmark that for later. To sum up what Neve actually said, is she was talking about how the shift in humanity that happens when you actually see humans in space as opposed to robotics. And so one of our main questions usually is, would you do a robotic mission or a human mission in space? And she said, even though robotics is a safe way to go, there's been that shift when we saw humans on the moon. And so I think that definitely is a wonderful comment. So I wonder kind of how you guys felt about that when you saw the interview.
Just using the 60s as an example, like, did you guys hear stuff about people freaking out when the Surveyor probes landed on the moon? No, it was when the humans landed. So I completely agree with that.
Yeah.
No,
Yeah.
Neve's extraordinary. She's right on the cutting edge of sort of bringing space and the humanities together, and
Yeah.
she gets it. I know her dream is to sort of be the artist in residence on the International Space Station, and that is about shifting people's perspectives upwards. So yeah, amazing person. I'm so glad you guys got her on for an interview.
Yeah, and it was
seriously.
on St. Patty's Day,
It
and it was live from
perfect.
Ireland, which was just
So perfect. So
like,
perfect.
that was
Way to
just-
do it,
That
so.
was amazing. Oh man! So our next comment is going to come from Ian Roberts off of YouTube. It says next Mars launch window is 2020. That must mean there's one open about now. Is anyone using it? I'm going to turn that to you guys. I was doing a bit of research on this.
Insight supposed to go? Insight is launching, isn't it?
Insight
Yes, it
is
is,
launching May
yeah.
5th.
May
Yes.
5th
There you
at
go.
4:05 a.m. Pacific Daylight Time, and
From
I will be there
Vandenberg.
for
I
that.
will be there
So,
too.
our first interplanetary launch from Vandenberg here in California, so I'm very excited about that. For 2018, that's it. That's the only thing that's launching to Mars. But then 2020 comes around, which it opens in July and it closes in September, and we've got the ExoMars rover, Mars 2020, Mars Hope, the 2020 Mars mission from China, and another Mars mission from India as well. So it looks like 2020, we're going to have a small flotilla of things heading off in the same direction
Flotilla.
at different times.
From memory,
So-
there was supposed to be another launch this year, but there was an issue with with a leaky instrument, or I can't even remember exactly what it was, but someone else was supposed to go this year as well.
Well, there was a plan a couple of years ago for NASA to put a couple of instruments on a Dragon capsule and send the Red Dragon mission to Mars. Although I don't think that was ever really officially planned, or if that was ever contracted, or if it was just something that was talked about and got leaked to the news. I don't know exactly, but that was something that was talked about that could have potentially happened this year. But
Yeah,
didn't,
and
so.
with the delays with Falcon Heavy, it probably would have made it a non-starter for this window anyhow.
Yeah,
So.
Falcon Heavy and Crew Dragon, let's focus on that.
Yeah, exactly.
Yeah.
So
Awesome. Our next comment comes from YouTube. It is Earfront. That is their name, Earfront. Cool. It says, I'm going to guess that Big Beef wants to see the humans eating our fellow Earthlings once we get to space. How did they get to you, Mr. Jared? How?
what is this
What is
referring
this talking
to?
about?
Yeah,
Big Beef?
I'm so confused as to what this is.
I mean, people don't taste like beef anyway. So there's that.
I don't know what
was
people
Googling
taste like. So I do know that the human body has, if you have to eat a human body, there is about 140,000 calories in the human body. If you
Whoa.
have to.
There you go.
I didn't know that, really?
Yeah.
Oh, whoa. Okay.
So if you can preserve it, that's like 2.5 months worth of caloric intake for a
Dodger's
single
saying
person.
here that
So-
it might be about your shirt from the last show.
My shirt from the last show. What
Wait.
shirt did I wear during the last show?
Was it the dragon that was yelling? No, that wasn't the Japanese. No, it was yelling in Japanese. Oh, what was your shirt from last show?
I don't know. I'm quickly running to our YouTube channel.
Oh, man. Guys.
Well, in the meantime, now you
What was
guys
he
know that if we ever
wearing?
get locked in here, we're apparently going to start eating each other.
Oh,
so.
I was wearing my Big Kahuna Burger shirt
Yikes.
last show. Okay.
Okay, so you said, how did they get to you? How? So,
What?
is this about Earthlings?
I don't know. I don't know. Let's move on.
Well, there's someone that says you've ever eaten tofu, man. I mean, I eat tofu. I like tofu. But we're not going to get into eating tofu. Wow, okay. So
Apparently, there wasn't a whole lot of questions from last week's show, because that is pretty much all that we have.
But we
Yeah,
got an
that's it.
Yeah, that was our last comment. But I do want to just throw out, one of you guys just commented about Jared's mohawk.
Coming back.
That's growing back from Robert Reorg.
It's an itty bitty warhawk right now.
Jared is
so-
regrowing it. Yes.
Yeah.
Awesome.
Cool. So,
He'll be aerodynamic soon.
yes, hopefully.
Yes, definitely.
I'll be bringing it back. So.
Very cool. So that just about wraps up our comments and questions from last week's show. So thank you so much, guys, for watching. Before we sign off, I want to give a huge thank you to our ground support citizens. These people give us $1 per episode on Patreon or $1 a month on Maker Support. They get their name in the show during the third segment, access to our exclusive citizen-only hangouts, and early access to After Dark as soon as it's available on demand. Now, next week, we're going to have an awesome roundtable discussions, but we want to ask you guys to give us suggestions. So head over to Patreon or Maker Support right now and start giving us suggestions, because this is going to be so cool. I'm like kind of excited, kind of nervous, because I feel like you guys suggest really amazing things. So that's going to be for our next week discussion. So thank you guys so much for watching, and we're going to head into After Dark now. This is going to be really cool.
For those of you watching live, you'll be able to see that right next, and for those of you not, that'll be posted in about a month or so. But yeah.
Yep.
Something like that.
Exactly.
All right.
Thank you for joining
Thanks,
us.
guys.
See ya.
Bye. I love how we all have the same NASA sticker.
We all,
Yep, the big meatball.
Where is the meatball?
That's how you know we're really space fans.
Yes.
Even though the worm's better, I've got the meatball.
No.
Hello, everyone, and welcome back.